Today we're going to look at two specific types of logs, what's known as the base 10 log or the common log, and the natural log, which is also a unique base. So if you look at these two expressions, log of 13 and then ln of 5, and you just saw these sitting on your page and you thought about what is it that these things could possibly mean. Well, we're used to a log with a base written, and log of 13 has no base to it whatsoever. And ln 5, if I wasn't aware that we're talking logs, this wouldn't mean anything to me at all. So now I need to start thinking about what is it that we could be referencing with this notation. So when we have log without a base, it's understood that we're talking about base of 10, and the ln is a log with the base of the number e, which we talked about in the first part of the chapter. We're going to find out that ln, the natural log, is so called because it occurs so often in science and in nature in the world around us. And the log base 10, we talk about orders of magnitude, powers of 10, 10, 100, 1,000. And so 10 is a much more easy base to work with. So looking at some key terms, the common log or common logarithmic function is a log function with a base of 10. And when you look at your calculator and you see the log button that's on your calculator, if you're looking on your phone or if you're looking on like a TI-30, you'll see the log button, and that turns out to just be the log with a base of 10. The natural log is a log function with base e, and you might remember that that e is an irrational number, and its value is about 2.71. So this is the base that your calculator uses when you use the button that says lnx. So taking a quick look at the function buttons on the calculator that's on your phone. So you've got a log, and the iPhone calculator happens to say log base 10 rather than just log. ln, though, is the same as log base e. So talking a little bit more about these concepts, if you click the box that is labeled Purple Math, it'll actually take you to this page, but it tells you a little bit about the log base 10, and you find out that some commonly used measurements are actually working in base 10. The Richter scale for earthquakes, a 2 isn't just one unit more intense than a 1. It's actually 10 times more intense than a 1. Each time your number goes up by 1, the strength is by a power of 10. So in algebra, when you see the word log, L-O-G, with no base, it means base 10. To the right, from Better Explained, and if you click on that box, it'll also take you to this particular page, it reminds us that the natural log in particular comes into play when we talk about compound interest. When money is socked away in a bank or as part of a money market or other type of account that's designed to pay interest, E is part of the calculation that we do for that. And we can also use it to do some back-of-the-envelope calculations regarding time required to save or produce a certain amount of money in compounding. So let's look at these examples. We want to take these examples that are natural logs and base e and convert them log to exponential and back. So remembering that ln 10 means log base e of 10 equals 2.3. Reminding ourselves that b to the x equals y, and log base b of y equals x. The log is the exponent. So let's look at this. E is our base. So log base b of y, equals x. So e to the 2.3, the log is the exponent, equals 10. Similarly, log of 1/4 equals negative 1.39. The log is the exponent. So a natural log has a base of e. Our exponent is negative 1.39, and that's going to be equal to 1/4. And you can check these in your calculator. Okay, conversely, now we have e to the 9th equals 8103, and we want to turn around and write this in the form of a log. So b to the x equals y, log base b of y equals x. So e is our base, so this is a log base e, which remember is natural log. Log base e of y, 8103, equals x, which is 9. So the log of 8103 equals 9. Similarly, remember that square root radical, that can be written as a fractional exponent. The square root of e is e to the 1/2. So now we have an exponent, e to the 1/2 equals 1.65. So b to the x equals y. I want log base b, which is e, of y, 1.65, equals the exponent 1/2. So natural log 1.65 equals 1/2. So that's converting back and forth with natural logs between the log expression and the exponential equation. Similar to 2 sections ago when we first started looking at logs, there's some particular special cases. So the natural log of 1 equals 0. Well, why is this? That means that 0 is the exponent on our base, so e to the 0 power is equal to 1. By definition, anything to the 0 equals 1. The natural log of e equals 1, because 1 would be the exponent on the base that would equal e, so anything to the first power is itself. E to the first equals e, and the natural log of e to the x equals x, because that's saying what's the exponent on e to the x that will give us e to the x. Similarly, with the common log, log base 10 of 1 is 0, because 10 to the 0 power is 1. Log base 10 of 10 is 1. What's the exponent on 10 that would equal 10? Well, it's 1. And if we have a power of 10 that we're taking a common log of, well, the power then becomes our log. So let's practice some of these special cases. So the log of e to the 4th. So remember, this is saying what exponent can I put on e that equals e to the 4th? So that value is 4. Log of the square root of e. Well, similarly, now I have e to the 1/2. So that's my exponent. The log base e of 1. What exponent can I put on e that equals 1? Well, e to the 0 is 1. So that exponent would be 0. Now some common logs. Log base 10 of 10 squared. So log of 10 squared, that means what exponent can I put on 10 that equals 10 squared? Obviously x equals 2. Common log of 1,000. Very similarly, that's the log base 10 of 10 to the 3rd. So what exponent can I put on 10 that equals 10 to the 3rd? X equals 3. And the log of 1/10 will give us -1. We can use these also to get some values of x. So our natural log of x equals 5. That's saying what exponent can I put on x that will give me 5? So e to the 5th equaling x. So if you plug that into your calculator, you get a value of 148.41. log of 1 over x equals 3. So now we have the log base e of x to the negative 1 equals 3. So e to the third power equals the opposite, the inverse of x. So this is e to the negative 3. Let's calculate that. 3, hit your inverse button, and then e to that power, oops. So that equals about 1/2. Now we've got a case where we've got a number subtracted from our argument, x minus 2. Well, if we remember that this is a natural log, log base e of x minus 2 equals 2, that means 2 is our exponent on e. E squared equals x minus 2, so e squared plus 2 will give us our value. So e to the second power plus 2, 9.39. One last thing we want to take a look at is something called the change of base formula. So we can see that our calculator can give us values for log base 10, the common log, and the natural log base e, but when we have a log of some other base, our calculator won't help us. And so we've got a change of base formula. Log base a of x can be calculated this way. The log base 10 of x over the log base 10 of a. So let's look at an example. The log base 2 of 9. So 2 is our base. And we want to know what exponent can I put on 2 that gives me 9. And obviously 2 to the third is 8, 2 to the 4 is 16. It's somewhere in between 3 and 4, but we don't know exactly what. So the log base 2 of 9 equals the log base 10 of x, that's 9, over the log base 10 of a, which is 2. So we go to our calculator. So 9 common log, 0.954, 2 common log, 0.301. We do that division, and we get 3.169. Similarly, log base 4 of 7. You can try this one on your own. Pause the video, check the answer. So the log base 10 of 7 over the log base 10 of 4. So the big issue obviously is in order to work through these common log and natural log problems, your calculator is going to help, either the scientific calculator that's on your phone or if you own a hardware calculator, TI-30. So be sure as you finish up the notes to do your notes summary. 3 things that you learned today, 2 things that you want to know more about, and 1 question you still have. If it helps to write things out in words, draw sketches, draw connections, graphic organizer to put your thoughts together in this space here, you can do that as well.